Hello, in this lesson, can we learn how to find the nth term in a sequence, and in this case, in linear sequences. So for example, if you are given a sequence like this, 3, 7, 11, and 15, and you are told to find the nth term, you are just simply being told to find a term which you can use to find the next value for this sequence without necessarily doing any further calculations within the sequence itself. So this is how we go about it. The first step is to count the number of terms we are given in the sequence, and in our case they are 1, 2, 3, 4. So there are 4, and I can just call them n. So n is 4. The second step is to assign the position of each of these terms in terms of the counting we did. So for example, when n is 1, the position of the first term is taken by 3. This 3. The position of the second term is taken by 7, and the position of the third term is taken by 11. The position of the fourth term, which is 15, is taken by 15, like that. Then from there, I need to find the difference between these terms to see if that difference is common. So for example, I can take the highest term, which is the first term, and it is 15. I subtract the third term, so it will be 15 minus 11, which is 4. Then I go ahead and take the third term, which is 11. I subtract the second term, which is 7, and the difference is 4. Then I take the second term, which is 7. I subtract the first term, which is 3, and the difference is also 4, like that. So now we have the difference of the 4 terms, and as you can note, the difference is just the same. It is 4. We have the difference, and we have the number of terms. So the next step from there is to take the common difference, which in our case is 4. We multiply by n. N is the term we are interested in finding, like that. So now it becomes 4n. Then we can just come in this sequence and check on the first term, which is 3, and we ask ourselves when n is 1, as we did here, when n is 1, we replace it here in this 4. So it becomes 4 into 1, which is equals to 4, like that. But you see, the first term is not 4, it is 3. So we ask ourselves, what do I either subtract or add to 4 to make it 3? And in our case, if we have 4 and we want to force it to be 3, we need to subtract 1. So now our complete nth term becomes 4n minus 1. This is 1. So this becomes our nth term. And then from there, we can just confirm if it is true. We can apply this formula to see if we get these terms, as they are 3, 7, 11, and 15. So we can start with the first term. I say when n is 1, then I have 4 into 1 minus 1, which now becomes 4 multiplied by 1 is 4 minus 1 is equals to 3. And I can go ahead and say, how about when n is 2? Of course, the second term. So it becomes 4 into 2 minus 1, which is 4 multiplied by 2 is 8. 8 minus 1 is 7, and the second term in our sequence is 7. So we go to the third term. When n is 3, here we see if we can get 11. So it will be 4 into 3 minus 1, which now becomes 4 by 3 is 12. 12 minus 1 is 11. So the third term is 11. And finally, we go to the fourth term, where n now is 4. We see if we get 15. So it will be 4 into 4 minus 1, which is equals to 16 minus 1, which is 15, and that becomes our fourth term. So, let's say somebody told you to find the 20th term for this sequence. You only need to know that if you are told to find the 20th term, then n will be 20. Then from there, you replace this 20 here. So it will be in the formula. So it will be 4 into 20 minus 1, and becomes 4 by 20 is 8 minus 1, which is 79. And the 20th term in this sequence becomes 79. So that's how we find the nth term in a linear sequence. Can we try another example? So in this one, you are told to find an nth term in the sequence where we have 20, 15, 10, and 5. As usual, the first step is to count the number of terms we have in this sequence, and in this case, we have 1, 2, 3, 4. We also have 4, so I can call them n is equals to 4. Then the next step is to assign each of these terms just the position in the sequence. So if I say n1 is equals to 20, meaning the first term is 20, then second term, which is n2, will be 15. Third term, which is 3 now, will be 10, and the fourth term will be 5, like that. Then from there, we can find the common difference between these terms, and see if that difference is the same. So I'll start with the highest term, which is 5 now, which is the fourth term, and it is 5. Yeah, and when I say the highest term, I don't mean in terms of value. This one, as you can see, this is the fourth term, but you can say 5 is bigger than 10. No. So when I say the highest term, I actually mean the last term we are given in that sequence. So in this case, it is 5. So 5 minus 10, the third term, which will be negative 5, because 5 minus 10 is negative 5. Then I go to the third term, which is 10 minus 15. So one becomes negative 5 again. Then we go to the second term, which is 15, minus the first term, which is 20, and it becomes 15 minus 20 is also negative 5. So as you can note, the difference in all the terms is just the same. It is negative 5. Then from there, we take this common difference, because it's the same. We take it, we can say it is negative 5. Then we multiply by n, where n now is the nth term we are interested in. And now that we have negative 5 minus n, then we ask ourselves, what is the value of the first term in this case? So, in short, what is the value when n is equals to 1? Well, so negative 5 into 1, it will be negative 5, like that. So, from there, you see this now. From our formula, it purports to be our first term, but in our case, we know our first term is 20. It is not negative 5. So we ask ourselves, what can we either add or subtract in negative 5 to give us 20? And in this case, I think it is 25, because minus 5 plus 25 is just the same as saying 25 minus 5, which is 20. And 20 is our first term. So in this formula of ours, now we take minus 5n, then plus 25, like that. Then this 25 we have added here, we can of course interchange it to be like this, 25 minus 5n, and this becomes our nth term. So we can use it to verify, actually, if we use the formula, if we can get the first, the second, the third, and the fourth term in this sequence. So we can start with the first term, which is 20. And when we have 20, it means then, and it is the first term, we have 25 minus 5 into the first term, which is now 5 by 1 is 5, so 25 minus 5 is just 20. So our first term is 20, correct? How about the second term? We take 29, 5 minus 5 into our second term. So it becomes 25. 5 by 2 is 10. So 25 minus 10 is 15. And 15 is our second term. So correct, correct. Then we go to the third term where we have 25 minus 5 into the third term, which is now 5 by 3 is 15. So 25 minus 15 is 10. And 10 is our third term. So correct. And then finally, the fourth term, we can do it here. We have 25 minus 5 into 4. And because 4 is is the fourth term, of course, then we have 25. 5 by 4 is 20. So 25 minus 20 is 5. And 5 is our fourth term. So our nth term formula is correct. It is 25 into 5 minus 5n. So that's how we find the nth term of a linear sequence. If you have any question, you can ask me, and also you can try to solve these questions and see if you really understand the logic. And in case of any complication, in case there is a place you don't understand, you can ask me. And bye for now. Let us meet in the next lesson.